In this video, we're going to take a look at a curve sketching example that involves some trig functions. So our function f of x is cosine x over 1 plus sine x. So our first step, we're going to find what are the x intercepts. Those x intercepts, those are going to occur. We have an output of 0. So when cosine of x is 0, as long as sine of x is not -1, and cosine of x is 0 at x equals pi over 2 plus 2k pi. Where k is an integer. Now, why could sine x not be -1? Well, we need cosine x to be 0, but we need that denominator to be non-zero. And so we have to throw out anywhere where cosine is 0, but that denominator is would cause us that denominator to be 0. So when x is 3 pi over 2, and then every odd multiple of that, we are going to have some kind of cancellation that happens here. All right, so those are the x-intercepts. What about the y-intercepts, or y-intercept? So y is equal to cosine of 0 over 1 plus sine of 0. So we'll have 1 over 1 plus 0, which is 1. That's our y-intercept. What is our domain? So our domain is all reals except for pi over 2, well, except for where sine 1 plus sine x is equal to 0, and that's going to happen when sine x is -1. So x is equal to 3/2 pi plus 2k pi. So everything except for 3/2 pi plus 2k pi. Those points, 3/2 pi plus 2k pi, those are going to be discontinuities. Those discontinuities, those are actually going to be vertical asymptotes. Perfect. Now what? Now we want to find our derivative. So our derivative, if we do that, we have low d high minus high d low square at the bottom, and away we go. If we do that, we will have negative sine x minus sine squared x minus cosine squared x over 1 plus sine x squared and so that is negative 1 over 1 plus sine x. And that might feel like a little bit of magic there. There was no magic that happened. The only observation that's made is sine squared x plus cosine squared x is 1. So negative sine squared x minus cosine squared x is negative 1. So we have negative sine x minus 1, or negative 1 minus sine x, which is negative 1 times 1 plus sine x, and so that canceled out. This is always negative. Except for the places where sine x is negative 1, but those are not in the domain. So it's always negative on this domain. So f is decreasing on this domain. Good. Let's find our second derivative so we can find those intervals of concavity. So when we find this derivative, our second derivative rather, we have cosine x over 1 plus sine x squared. This derivative is 0, would tell us that x is pi over 2 plus 2k pi, for k being an integer. That second derivative does not exist when x is 3 pi over 2 plus 2k pi. And so our sign chart, we're not going to create this full sign chart, but we're going to get an idea of what's happening. So let's go from negative 3 pi over 2 to negative pi over 2. Let's go from negative pi over 2 to positive pi over 2. Pi over 2 to 3 pi over 2, 3 pi over 2 to 5 pi over 2. All right, so from negative 3 pi over 2 to positive to negative pi over 2, plug in something there, and we will get a sign for the second derivative that is negative. Plug in something between negative pi over 2 and positive pi over 2. We'll get a positive, and we get a negative, and we get a positive, and then a negative, and then a positive, and a negative, and a positive, and a negative. So this is going to alternate between increasing and decreasing at every odd multiple of pi over 2. Between concave up and concave down at every odd multiple of pi over 2. The end behavior, there's no nice, the end behavior does not exist on this trig function. So let's draw our graph. And our graph is going to look something like this. So we have an intercept here. Something that does this. So it looks kind of tangent-y, right? Reminds us of a tangent graph, kind of. All right, that is all we got. We will see you next time when we look at taking these ideas and applying them to word problems. We will see you there.